The state of Gujarat realized that for development to be sustainable, ecological and economic efficiency as the basis of future strategies in business was essential. The Department of Forests and Environment, Government of Gujarat, has spurred an initiative for promoting cleaner production as a tool for improving environment and economic performance for the small and medium enterprises or SMEs. Cleaner production is defined as the continuous application of an integrated preventive environmental strategy applied to processes, products and services to increase overall efficiency and reduce risks to humans and the environment. Cleaner production can be applied to the processes used in any industry, to products themselves and to various services provided in the society. The UNIDO National Cleaner Production Center NCPC program was established in 1994 to build local capacity to implement cleaner production in developing countries and economies in transition. The program is based on the premise that cleaner production will only be truly integrated into the country's industries and policies if local capacity is in place to sustain it. There are 43 National Cleaner Production Centers or NCPCs that have been established through bilateral, governmental and other forms of assistance. The 4 regional CP centers of India are Gujarat Cleaner Production Center, Karnataka Cleaner Production Center, West Bengal Cleaner Production Center, Punjab Cleaner Production Center. These CP centers are financially supported by the various government departments while technically supported by NCPC. A proactive step, Gujarat Cleaner Production Center GCPC has been established in GIDC in the year 1998 with technical support of NCPC and UNIDO. Gujarat Cleaner Production Center plays an important role in educating, permeating and providing knowledge as well as expertise to tackle various environmental issues that the various sectors of the industry shall need to address in the current scenario. GCPC is widely involved in conduction of various orientation programs, training programs, CP assessment, CT assessment projects, etc., which have successfully spread the message of cleaner environment in various sectors of the industry. GCPC has taken up demonstration projects in various sectors like dyes and dye intermediate, pharmaceutical, textile, dairy, ceramic, chemical and petrochemical. GCPC has also been selected as ENVIS or Environmental Information System Center of MOEF, Government of India. Though GCPC is a regional cleaner production center, UNIDO has recognized the center at par with National Cleaner Production Center by considering the center as a partner of RECP or Resource Efficient and Cleaner Production. The Department of Forests and Environment has assigned GCPC a project of CP implementation in that sector. The project is to create cleaner production opportunities for improving resource efficiency and preventing the release of contaminants to the air, water and land and implement some of the options.
Whenever we mention about industries, there is also mention about pollution, which is inevitable in industries. Well, to address this problem, we started with what we call end of pipe concept. So later on, there was a talk of preventive step, and that is what cleaner production is. The Gujarat Cleaner Production Center has a separate entity which is registered under society. Well, the major activities taken up by GCPC is to make people aware about this concept. After creating this CP assessment, we implement also so that industries can get advantage, economical benefit as well as improvement in environment. And then we arrange dissemination program. Under this same project, even our Department of Forest and Environment, state government realized, and a project was given to us, particularly this project of implementation of cleaner production tools which are already generated. So the GCPC started implementing, and while implementing, GCPC team, which is expert of chemical, environment engineers and environmental scientists, generated additional source. So we generated so many options, what we call simple tools like good housekeeping, process optimization, raw material optimization, possibility of recycle and reuse. Industries also have realized that it is in their benefit, they can reduce waste right at source. Also while doing so, there is economical benefit and overall improvement in environment. So these selected industries have also implemented the already CP generated tools and also additional CP tools generated by GCPC. The results are very fantastic. They have realized that that is required. We have documented that result, and also as I told you that we need to disseminate the result of this. So we arrange a good dissemination program wherein we don't speak anything, but the industries who have implemented, they come to the dais and then they tell their friends that what they implemented and what benefit they got. We are thankful to the Department of Forest and Environment for giving us this project, and I am very hopeful that this CD, which consists of the applicable tools and already implemented tools with the benefits, will help industry so that directly they can implement and get benefit of environment as well as economy.
India is the largest milk producer in the world. From being a milk impoverished nation to a top producer has been a strenuous and almost miraculous climb. In India, about 46% of the total milk produced is consumed in liquid form, and 47% is converted into traditional products like cottage butter, ghee, paneer, khoya, curd, malai, etc. Only 7% of the milk goes into the production of Western products like milk powders, processed butter and processed cheese. The remaining 54% is utilized for conversion to milk products. Among the milk products manufactured by the organized sector, some of the prominent ones are ghee, butter, cheese, ice creams, milk powders, malted milk food, condensed milk infants food, etc. Of these, ghee alone accounts for 85%. It is estimated that around 20% of the total milk produced in the country comes from Gujarat. Gujarat is a major milk producing state of the country, and it is also booming today and is one of the largest cooperative sectors of the state. The Gujarat Cooperative Milk Marketing Federation Limited, the apex marketing federation of 12 districts milk unions of Gujarat, having a membership of 25 lakh milk producers, has crossed another milestone. GCMMF coordinated the operations of the union and marketed milk and milk products. As the operations were based in Anand, Gujarat, this came to be known as the Anand model. There are about 45 dairies in Gujarat. The farmer in the village is now assured of a better future thanks to these cooperatives. Today, with about 100 lakh farmer producers, Indian dairy farmers have been shown the way to prosperity and health. Therefore, this project will help in achieving multiplier effects by implementation of CP in dairy sector of Gujarat.
We welcome Gujarat Cleaner Production Cell from Gandhinagar to Vidya Dairy. First, I would like to say that cleaner production has become imperative or badly necessary in the today's economic era, and any industry has to improve productivity or energy conservation or environment efforts, has to implement in one or other way cleaner production methodology. Vidya Dairy has been specifically established to impart hands-on experience to the BTech Dairy Technology students of Anand Agriculture University. Over the years, it has been realized that any theoretical knowledge is to be converted into skills, and for converting skills, knowledge into skills, hands-on experience is a must. And therefore, in the year 1994, with the help of NDDB, Gujarat Corporate Milk Marketing Federation, Amul Dairy Anand, and Anand Agriculture University, the dairy was established. And so far, we have trained more than 700 students, those who are working in the various fields, dairy industry, in all corners of India, and many of them have gone abroad also. In the year 2000, Vidya Dairy thought of making all efforts for cleaner milk production, because it is a training dairy, and to inculcate culture among students about cleaner production. We had taken certain initiatives, and those initiatives included total quality management, bringing awareness about energy, environment, productivity and quality among the emerging dairy technocrats, those who are in the third year of BTech Dairy Technology program. We have started measuring, because without measuring we cannot improve. Therefore, we started measuring the steam consumption, water consumption, and what type of the load is going into the effluent treatment plant. Similarly, how much energy is consumed in refrigeration, how much energy is consumed in cold storages. Likewise, how much steam is consumed. All measurements we started so that we can control the consumption of consumables, energy, etc. in Vidya Dairy. Since then, we have been meeting regularly every month to review the progress of dairy with respect to its quality, productivity, environment and energy, and safety also. We started internal benchmarking. Against that, we started showing improvements, and similarly, we have strengthened our ISO 9000 as well as food safety, or ISO 22000 at Vidya Dairy, and we were trying to achieve ISO 14000, which we have achieved in the year 2009. Then, with a view to improve training as well as improve the productivity, we took an initiative of providing automation in the plant. Thereby, we have improved our processes. Similarly, we were consuming furnace oil in the boiler. We thought of making a cleaner fuel, and in the form of CNG, we are now using gas as a fuel in the boiler. And finally, with a view to bring transparency as well as more accuracy in our operations, we have implemented entrepreneur resource planning ERP project at Vidya Dairy, which we are on the verge of completion. Apart from these initiatives, when we started taking actual steps in the plant, my all staff, students and workers have cooperated me to an extent that today we are very happy to state that we are commercially viable. But the exact measures which has been taken by in the plant as well as in the engineering services area as well as in the effluent treatment plant, I request my colleagues to throw some light on that. So I request Mr. Birendra Kumar to give you some idea what type of the measures they have taken in the dairy plant area to implement cleaner production.
Environmental and health impacts by the dairy sector. Dairy sector generates waste streams like solid, liquid, gaseous. The dominant environmental problems caused by dairy processing is the discharge of large quantities of liquid effluents. Dairy processing effluents generally exhibit the following properties: high organic load due to the presence of milk components, fluctuations in pH due to the presence of caustic and acidic cleaning agents and other chemicals, fluctuations in temperature, discharges significant loads of organic matter in the effluent stream. Air emissions. There are 4 sources of air emission in the dairy industry. Exhaust gases resulting from fuel consumption used to generate steam from boilers. Solid wastes. The main sources of solid wastes are the workshops and garage, packing wastes, iron scrap, outdated solid products.
To initiate measures for energy improvement and cleaner production, we took following steps in the plant. First, a step was reduction in milk pasteurization temperature. Previously, we were using heating temperature 78 to 80 degrees centigrade. Now we reduced it by 2 degrees centigrade, that is now milk is pasteurized at 76 to 78 degrees centigrade. So by doing this we saved energy, and we have also increased the regeneration efficiency of the milk pasteurization plant from 90% to 93%. This also resulted in saving of energy. Another step taken was conversion of milk packaging machine from pneumatic to mechanical types. So by doing this, we saved consumption of compressed air, thereby resulting in the saving of electrical energy. And this also resulted in saving of milk pouch because the number of leakage pouches was reduced, pouch length were also reduced. So we decreased the wastage. Another step taken was conversion of ice cream mix preparation plant from batch type to continuous type. We started mix preparation by using a HT/ST pasteurizer. So by doing this, we saved steam consumption and thereby energy.
Implemented cleaner production options. Modification in manufacturing process and milk processing by reducing pasteurization temperature from 78 or 80 degrees Celsius to 76 or 78 degrees Celsius. In the process of pasteurization, processing heating temperature was 78 to 80 degrees Celsius. Now it was suggested to reduce the temperature from 76 to 78 degrees Celsius and chilling below 4 degrees Celsius. Cost benefits analysis in terms of energy saving by reducing pasteurization temperature. Investment in reducing pasteurization temperature is nil. Annual saving Rs 0.94 lakhs. Simple payback period immediate. Environmental benefits. Reduction in heating temperature resulted in energy saving. Reductions in energy consumption minimize the emission of greenhouse gases. Change in manufacturing process in milk processing by changing pouch filling machine from pneumatic to mechanical type. Loss of milk in pneumatic machine. Total pouch packaging equals to 1,20,000 pouches per day. Weight variation per pouch 2 ml per pouch or 500 ml. Price of milk Rs 20 per litre on an average. Saving of milk per day of production 240 litres per day. Annual saving of milk Rs 17,52,000 per year. Cost of mechanical packing machine Rs 6 lakhs. By reduction of air compressor units consumption, total unit saving of air compressor 7.5 units per day. Unit saving per year 32,850 units per year. Cost of 1 unit Rs 5.70. Annual saving Rs 1,87,245 per year. Total saving from converting pneumatic to mechanical pouch packing machine is Rs 19,39,245. Payback period is 4 months. Benefits of reducing pasteurization temperature and converting pneumatic to mechanical packing machine. No weight variation in milk quantity. Reduction in packing roll quantity. Low maintenance cost. No air requirement. Cleaning in place or CIP. Started collecting the condensate of CIP plate heat exchanger which was earlier drained. Cost benefits analysis. Amount of condensate recovered 1,200 liters per day at the temperature of 80 degrees Celsius. Investment Rs 25,000 which is one time. Annual saving Rs 1.12 lakhs. Simple payback period 3 months. Environmental benefits. About 1,200 liters of steam condensate at 80 degrees Celsius is recycled every day, resulting into energy as well as water saving. Steam condensate recycle is useful to reduce freshwater consumption. It results into saving of energy. Reductions in energy consumption minimize the emission of greenhouse gases. Cleaner production measure in ghee manufacturing by starting separation of serum obtained after pre-separation to recover fat which was drained earlier without separation. Cost benefits analysis. Amount of fat recovered 20 kgs per day. Cost of fat Rs 179 per kg. Investment nil. Operation cost Rs 15,000 per annum. Annual savings Rs 13 lakhs 6,700. Simple payback period is immediate. Environmental benefits. Every day 20 kg fat is recovered from serum. Reduced polluting load in the effluent treatment plant. In cheese and paneer manufacturing processes, it is suggested to start separation of whey to recover milk fat and creating separate facilities in effluent treatment plant for collecting as well as treatment of whey, as well as start sending whey to other dairy or direct user for further processing, thereby reducing polluting load on ETP. Cost benefits analysis. Amount of fat recovered from whey 35 kgs per day. Price of fat Rs 179 per kg. Investment Rs 40,000. Operating cost Rs 65,000. Annual savings 20 lakhs 71,750 per year. Payback period immediate. Environmental benefits. Every day 35 kg fat is recovered from the whey, which reduced polluting load in the ETP. Cleaner production measures in ice cream manufacturing by starting salvaging 6% losses of cassata and roll cut mixture by disposing the waste ice cream as scrap. Cost benefits analysis. Amount of waste cassata ice cream 6,895.5 liters per year. Amount of waste roll cut ice cream 4,876.5 liters per year. Rate of scrap cassata ice cream Rs 18.06 per liter. Rate of scrap roll cut ice cream Rs 25.41 per liters. Annual savings Rs 2,48,443 per year. Environmental benefits. Reduced polluting load in the effluent treatment plant. Installation of anaerobic digester for treatment of whey and generation of power from the gas. In the aerobic reactor designed by SPRERI. According to estimates, 12,000 liters per day of whey containing 80,000 milligrams per liter COD can produce 216 cubic meters biogas per day with 70% methane content. This gas can be used to run a 12.5 kVA generating set round the clock or can be used as fuel in boiler to save 150 liters of furnace oil every day. This will help in turn to save about 400 units of electricity per day. The installation of the aerobic filter and gas storage unit has been completed successfully and filter was charged with the active culture biomass and medium strength dairy effluent having 15,000 to 20,000 milligrams per liter COD. Cost benefits analysis. Amount of whey 12,000 liters per day. Biogas generation from this whey 216 cubic meters per day with 70% methane content. Saving of furnace oil of boiler 150 liters per day. Cost of furnace oil Rs 36 per kg. Investment of anaerobic digester installation Rs 7 lakhs one time. Saving of furnace oil Rs 5,400 per day. Annual saving in terms of unit saving Rs 19 lakhs 71,000 per year.